density concept with bacteria, specifically looking over density. Okay, so the controlling factors, density controlling factors are going to be mass is the number one thing I told you. Think of density or think of exposure. The first thing that will come to mind is mass. First thing, okay? Then you can think of KVP because it does have an influence. As we discussed the last 20 minutes of the class last Friday, I was explaining and people were asking me about, well, how come is that? And it's because you have more interactions, right? If the kinetic energy, which is what you do when you increase KVP, the kinetic energy of the electrons flowing from the cathode to the anode increase, then you're going to have more bouncing around of that electron, okay, from atom to atom. And instead of having, the average amount of interactions, you're going to have more, okay? And so, therefore, if you have more interactions, you're going to have more photons. At the same time, you also increase the energy, right? And we'll come back to that concept, but what is important to recognize is when you increase KVP and you're not doing anything else, you're not changing distance, you're not changing mass, you're not changing anything else, but just strictly changing KVP, okay, you are increasing exposure. Okay. If you're increasing exposure, if you're using film, that will increase density. All right? I think Carlton and maybe Bush on one or two paragraphs, and a couple of you pointed at me, and I had talked about that before. They are wrong. Okay? Carlton is wrong. Right? I don't know how to put it. Okay, so when you see that, when you read that you don't increase, maybe automatically, he's a technologist, so maybe he's thinking, well, you will adjust mass. But he's not saying that with that statement. Are we good?
Okay.
All right. Everybody? Okay. All right. And then there are other factors that influence density. We'll take a look at those. So, changes in mass. Okay, once again, this is when we talk about density. Remember, we're talking about the darkness. We're talking about the blackness, the opaqueness of an image. Okay? And so this is a term that is used mainly for film. Okay? You still hear technologists, especially the older texts, still talk about density, but in digital systems, don't, because the density is determined really by the algorithms that you're using. Okay, so it's not so much about the exposure, but about the algorithms. So this portion, and I'll try to point it at you, this is about film. So when we said that a minimum of 30% change to visualize changes in density of a radiographic image, which means is that if you're changing 5 or 6 mass, it's not doing anything. Okay, and if you're looking at digital systems, it is the same. For example, if you're doing an abdomen, okay, let me put it in this context. You're doing an abdomen, 80 kVp and 40 mass, okay? And your technologist tells you, oh, okay, let's go up to 50 mass. You're not doing anything when you're going up 20 mass, or if they tell you we're going to go, from 40 to 50. 10 mass is not doing anything. The increases, even with film, increases have to be made of at least 50%. Write that down. It's not here. Write that down. Not 30, 50.
So
No, don't cross it out.
So that includes film and digital?
I'll come back to digital. Film. With film, if you're going to make changes in mass, those changes have to be done by at least 50%. So what is this 30% saying? The 30% is saying that if you were using a densitometer, then you begin to see changes of 30%. But to the naked eye, to the visual eye, especially an untrained eye, 30% is nothing. Okay? Now, so that's what I said. For you, the X-ray technologist, to see a visual change, Okay, before you begin to see differences, you need to increase your mass by 50%. Okay, does that make sense? Good. All right, now let's go to digital systems. Remember, digital systems are directly, the image receptor captures radiation directly proportional, isn't it? Yes or no?
Yes. Can you repeat the question?
It was not a question. It's a statement that I'm making. I'm saying that with digital systems, the image receptor captures the radiation directly proportional. Okay? Right. And so, with digital systems, at 30% in mass, it does represent 30% increase in exposure. If you're going to write this down, what I just said, write it like I said. So otherwise you're going to get mixed up. Okay? With digital systems, 30%, a 30% change in mass does represent a 30% increase in exposure. Now, comma, okay. Now, does that, and this is a question now, Newman. Now, the question is, does that represent a 30% increase in darkness? No, it doesn't, because you have an algorithm again that is reconstructing, that is rebuilding that image to fit the density that the radiologists like, regardless of your technical factors. Okay? We talked about this before. So it is, so this applies, this 50% or 30% applies to film as technologies and film and how we perceive it. With digital systems, now, you can try it. You go up 30% with a digital system and look at your exposure index. Look at the exposure index. It will be proportional. I mean, it's not 100% effective, but it will go up about 30%. Okay? The exposure index, your S number, your exposure index number, your, I don't know what other numbers they call it. Okay? All right? What do you guys call, what do you guys for Wednesday? I want you to find out when you go to your hospital. I want you to remember. I want you to find out how the index, your exposure, is reported with your systems. Okay? Either an S number, an exposure index number, and I want you to give me some range values. Okay, that's a homework. Okay? Wednesday.
How many do you want? Do you want like an abdomen range value? They're all different. Yeah, numbers.
Yeah, give me a, you're gonna give me an abdomen, you're gonna give me a chest, you're gonna give me an extremity, hand, wrist, elbow, okay? You're gonna give me a knee, and you're gonna give me a shoulder. Okay.
You mean with the range?
Mm-hmm.
Exposure index range.
Okay. First and foremost, the first thing that you should answer on your homework will be how in our system, okay, it says Fuji system, our exposure index is indicated by the S number. That's the first thing that I want to see.
Fuji system expresses.
Okay. The next thing is, and these are some examples of the ranges that our S number are acceptable. Okay. The 5 body parts that I told you. Okay. And that's it.
Abdomen, chest, extremity, shoulder, and
Knee. Okay. Are we good? All right. So let's go back here. All right. Make changes. So what is recommended? And now let's go back to film. No talking. Okay, let's go back to film. All right, make changes in doubles or halves. Okay, this is what I said. Either you're going to increase your mass by, you double it by 50%, or you will decrease it by 50% for you to be noticeable. Otherwise, you don't see it. You go with 30%, you're not gonna see it. Okay, that's why deep inside of me I laugh when technologists tell students, "Oh, increase 7 mass." It's not doing anything, much less with digital systems. But even with film, that's nothing, unless it corresponds to 50%. So if you were using 14 mass and now you cut it in half to 7, yeah, well, in that case, yeah. But if you're already using, say you're using 80 mass, and some technologists tell you, oh, increase 10 mass, that's nothing. Nothing. You're not gonna see anything, okay? So changes have to be done for it to be detectable with the densitometer 30%. For you, the naked eye, you need to change it about 50. I mean, and if you have a radiologist, a senior tech, yeah, when you make changes about 30%, you begin to see changes. But for the majority of people, techs who've been techs for maybe 5 years or less, your eye's not, even though they might tell you that you're cute. Anyway, repeats, okay. Too light or too dark, okay. It is recommended that when you do have to do repeats because an image is too light or too dark to make changes in mass, okay, because it's easier. Why is it easier? Because it's directly proportional, right? And so it's easier to make changes with mass instead of changing KVP or changing your distance. Distance you shouldn't change it, but it's other factors that you can change. Are we good?
So I have a question.
Mm-hmm.
So when I change mass in the double, it means I have to change the KBP because it's a 15% rule. It's not.
I mean, it depends. Is that what you want to accomplish? You want to maintain the density? In this case, we're talking about density. And if we want to double the density, you leave your KVP the way you had it. What determines if you change KVP or not?
It's the power is not enough to go to the X-ray.
How do you know?
See, the picture is not clearly for detail. The picture.
Detail has nothing to do with technical factors. Remember? Let's cover a new thing here. Okay?
You have some
All right, so how do we determine? Come on, guys. How do we determine? Penetration, the penetrability. That's then and only then is when you change your KVP. If you don't have enough penetration, or if you have too much penetration, then you change KVP. But if you're happy with your density, or if you're not happy with the density, then mass. That's what you want to change. Angela?
Yeah.
We're good? Okay. Makes sense?
Yeah. So I just think it's not related with the 15%, right?
Nope. Nope.
It depends. We see the picture and what we want.
Yeah. When do we use the 50%?
When?
Yeah.
When I use it, if I see the picture and I am happy with the power of the X-ray beam, so
How can you be happy or unhappy with the X-ray beam?
I see the picture is not clearly to see. For example, I want to see the T-spine, but the picture is not show bone detail for the C-spine. So I think it's not enough the power of the beam. So I increase the 15%.
And what is the 15% going to do?
I just is 15%.
Let's ask your friend Jackie Valentin. Okay. Jackie, when do you use the 15%? Ethel.
Is it when the picture's too light?
And what is the 15% rule going to do?
Gonna darken it?
How much?
50%? No, I'm just kidding. It'll darken it enough where you see where you could see the anatomy. If you higher it by 50%.
Huh? Hilda?
I think if we increase 50%, so it
Is
will,
50 or 15?
I heard 50. So are we
50%
talking
in
about
KVP?
15 or-
I'm asking, 50% in KVP?
Oh, no.
So what is the 50? She's talking about the 15% rule. So I want to know if you
Oh,
guys,
okay.
if you guys remember what the 15% rule. I'll ask you later. I know you know.
No, I don't quite remember.
Okay. Rachel?
So now you increase your KVP by 15% and then you double your mass. Is that?
So you're saying you increase the KVP by 15% and you increase mass by 50%? Is that what you said? Or double it? Is that what you said?
Yeah.
Okay, not quite. Go ahead.
Me?
Yeah.
A 15% rule means if you raise the KVP 15%, is equal to a 50% mass increase? Or, I'm sorry, equal to doubling the mass.
Doubling the mass, exactly. Now, that still is incomplete, okay? Did you
In
hear
a
the
certain,
difference,
in a certain
Rachel?
range.
Did you hear what she said? Tell them.
If you increase the KVP 15%, it's equal visually to doubling the mass.
Okay,
Yeah,
good.
in a certain range.
And so, when you double the mass, what is it that you're doing?
Increasing
You're
the
doubling the
exposure.
You double the density. Don't tell me increasing, because if you just said increasing, what I'm saying, when I'm very direct and saying double the mass, what you should say is double the density. Okay? So, when you make a new one, Ashley Valentino, Ethel Cruz, Rachel Kreider, Hilda, when you increase 15%, okay, if you apply the 15% rule in KVP, you increase it by 15%, that will be the same as doubling your density, doubling the mass. Make sense? It will be, okay, that will be the same. Now, okay, if I increase 15% in KVP, does that mean that I double the exposure? Since you double the density?
It's just C.
My question is, all you have to say is, all right, my question is, all right, do you double the exposure when you increase your KVP by 15%?
Yes.
I'll say yes.
Okay, explain.
Because you're doubling the mass, therefore you're doubling the exposure.
You're not doubling the mass. It said 15% increase in KVP.
I forget what the rule is, but I remember reading somewhere that if you increase 15%, you are doubling the exposure.
It's yes.
Okay, anybody else agrees with Dennis? Christina?
You're asking if you increase the KVP by 15%, if you'll double the exposure? I think so, but you won't double the darkness because of the algorithms?
This is film. This is film.
Oh.
All right.
Then
No, guys, no.
No.
Okay, let me repeat it, okay? We talked about this last week, but why don't you write it down, because it's important. When you increase your KVP by 15%, yes, you double the density, but no, you do not double the exposure. Okay? To double, and listen carefully here, and maybe you want to put it on red because this is important, it's an important concept. If you can understand this, you're already passing 15% of your national boards, guys. It's important. It's going to be there. It will be there. If you don't understand it, well, there you go, you've lost your 15%. So, Okay, so to double, and listen carefully, to double the exposure by KVP alone, not touching anything else, not touching distance, not touching mass, you need to increase your KVP by approximately 40 to 41%. Now, let me ask you this, do you see the difference between exposure and density? Okay, the more exposure you have, okay, the more density you have. The problem, okay, the issue with KVP, and that's why it doesn't work. Garrett, not her, me. Question?
Just need, remember the percentage increase in KVP.
40 to 41%. Okay, so when you increase KVP, you're not only increasing the number of photons, right? What else are you increasing?
The power.
The power, the energy. And by increasing the energy, you're also increasing the number of scattered radiation that is reaching the film. And so you are increasing contrast. I mean, you're decreasing contrast, but you have more fog into the film. That's why it looks darker. Are you following me? It's two factors that come into play when you change KVP. The density, okay, the darkness, but also you're changing the contrast when you increase KVP, or you decrease it, either way. Okay? So, going back to my question was, do you double the exposure when you increase your KVP by 15%? The answer is no. The answer is no. Okay? But on the other hand, you double the density. You're doubling the density because now you have more photons reaching the film, more primary photons, but also you have more scattered radiation increasing. Are you following the logic there? Yeah.
So what does it mean to double the exposure? Are you doubling the energy?
No.
The number of photons?
No. When you say double, when we double the exposure, we double the number of photons.
At equal strength.
No. Remember, intensity or number, okay, is one thing. Energy is another.
Right.
Okay. When you change mass, in mass alone, all you're doing is increasing the exposure, increasing the number of photons,
right,
increasing the intensity. Okay?
Yeah.
And it's directly proportional. Okay? And it is also directly proportional with density if you're using film. Okay? Now, with KVP, it's not. Okay? With KVP, visually, to increase the density, to double the density, you will need to go up 15%.
Right.
Okay, within the range that I gave you the other day. Okay? But that doesn't mean that you're doubling the exposure. You're not getting double the amount of photons. And so the question is, how come are you getting more density? And I already gave you the answer. You're getting more density because not only you have an increase in photons, but also you have an increase in scattered radiation. See it? Okay, did you write it down? Yes.
So is this a better way to increase density as opposed to doubling the mass?
That's the easiest way. And my recommendation for you, okay, and I know some of you are very smart, and hopefully you don't get in trouble for that. But my recommendation is just to use mass if you need to make changes in density. Okay. Now, if you need to change the KVP because why? When do you change KVP, guys? Lack of penetration. Then use the KVP. And the other recommendation that I've been emphasizing for you guys is to stick to one factor. Stick to one factor. Stick to either mass or KVP. Don't change both. Okay? Don't change both because you're gonna get confused. And the problem is if you get confused, well, you know, you can go back, read your book, read your notes, and you know, you finally someday you'll get it. But in the meantime, you're exposing patients. That's the problem. Okay. Why don't we stretch a little bit? Take a 5-minute stretch break and